Here is a list of the straightforward properties that hold for addition and multiplication of the mod tables. First of all, we have properties for addition, and they essentially are proved just by noting that they're true for ordinary addition. For example, a plus b is equal to b plus a for ordinary addition of integers, and then you just take the remainder after dividing by n, and that gives you the result as stated here. Similarly for this, the associative rule, in other words, if we add a to the result of adding b and c, we get the same as if we first add a and b and then add c. All these I mean to be modular addition. Similarly, a added to 0 gives me a, and finally, for every a in 0, 1 up to n minus 1, there is a number which also in that range, which when added to a gives me 0. So if a is equal to 0, then I take 0. 0 plus 0 is 0. If a is equal to 1, then I add to that n minus 1, and I get n, which modulo n is equal to 0. And likewise, if a is 2, then we add to a n minus 2, which gives me n, which gives 0 mod n. So that's noted down here for the proof of 1.4. Likewise, for multiplication, we have the following three properties. We have that the order does not matter, that a times b is equal to b times a, that a times b times c is equal to a times b times c, and also that a times 1 is equal to a. Now what's missing here is some analogue of this. So the analogue we would like is that a multiplied by some other integer gives us 1. Now this is not true for ordinary integers. If we want to find an integer which multiplied by 3 gives me 1, we can't do it. We have to take a fraction, a so-called rational number, 1/3. But in the case of the modular tables, we actually get, provided n is prime, that every integer a not equal to 0, there is another integer in the mod table which when multiplied by a gives us 1. And we've already seen that in the case that n is equal to 7. And we also saw that in certain cases it was true when n is equal to 8. And we'll discuss this more in future slides. And finally, we have this so-called distributive property, which is also true for ordinary integers, and that is that a times b plus c is a times b plus a times c. And the proof again is just observing that this is true for ordinary addition and multiplication, and then essentially just taking residues, remainders, modulo n.